Good morning, afternoon, good day, whatever it is. We're on to
Good.
section 4.2. We're going to graph us some polynomials. In the last section, we talked about the end behavior and we talked about John Travolta and touchdowns and some wiggles in the middle, and we're going to put that all together to make a graph. Okay, so let's jump on into it.
Bagels in the middle.
Yeah, well, that sort of got awkward last time. I really don't want to have that conversation again. Okay. So what we're going to do with these problems is we're going to look at the leading term and try to remember about the end behavior and determine what we expect it to look like. We're going to look for and find those x-intercepts or those zeros. And then we're also going to find the y-intercept. Putting all that together, we can try to connect those to make the shape that we're expecting, and making sure we have the correct number and nature of zeros. That's what we're talking about, whether it crossed the x-axis or it was bouncing off of the x-axis. And if there are any other points we'd like to plot, we can plug in other numbers to get other points that might help us refine the graph and make it more, okay?
So another one you might want to find, guys, is like the point between two zeros where it turns around. We could try to locate that point.
That turning point. We talked about
those local mins and local maxes. We didn't call them local, though. What did we call them?
Relative.
Relative, that's right.
They had to put you in the right place, put you out of the way again.
Am I in that corner now?
No, you're in the bottom left corner.
Okay.
Because the graph was where I had you,
Am I looking up at the screen right now?
Anyway, now you're looking at the graph. Now you are.
Okay. Got it. Okay.
So, all right, looking at this polynomial, we want to begin by doing the leading term test. So let's look at -2x to the third power. What did that tell us from the last section? Because the degree is 3 and 3 is odd, I know it's going in opposite directions because it's John Travolta, okay?
Yeah.
And I also know that the -2 tells me that the left side is going up. So I expect it to kind of go up that way, and that's not really part of the graph, but I expected n doing those things.
Right.
Okay?
Right. And he meant to say that because it's negative, he expects the right side to end up decreasing.
Yes. Okay. Well, I expect the left side to go up and the right side to go down. I didn't thought.
Yeah.
So that's not part of the graph, but I know that the ends have got to be going in those two directions. Okay?
Well, it's potentially part of the graph if that's where it ended up, but.
Oh my gosh, I did blue. I wrote in blue as my primary color. Can I start this video over?
No, you cannot start over. Just keep going. Just keep going.
It's okay. I'm sorry. She got mad at me for not using pink in one of the examples.
So just so we're clear, I was fine with him writing in pink. I didn't like that the words were in a red that clashed horribly with the pink.
Okay. So we're going to start by finding the zeros. Okay. So we're going to set the expression equal to 0, and we're going to try to factor it. So I see a GCF of -2x squared. What will that leave me? X minus 4. So what are my zeros now? I got a 0 of a 4, right?
So you got -2x squared equals 0. And this is some kind of important to talk about. So you've got that.
Got the 4.
You got the 4.
Yeah, but I don't see no other 0 there.
But we got to talk about the -2x squared out front, right? If I were going to solve -2x squared, now, if it didn't have an x in it, I wouldn't care, and I'd let you keep doing what you're doing. But because there's an x involved, we need to set it equal to 0 and figure out what's going on here.
Okay.
So if I divide by -2, I get x squared is equal to 0. Not a lot happened.
Can I divide? Can I divide 0 by a negative?
Yeah, it's fine.
Oh, okay. Yeah, I can do that. Yeah.
0 can be in the top, not the bottom.
Oh, we've had this conversation, I think, once.
We did. No division by 0. We went. The last video, we didn't say anything.
Oh my gosh! Oh my gosh! We have to re-record.
So we get x equals, we get plus or minus 0 here. What do you think about that, Mr. Bobby?
So I got to put a point at +0. And then another point at -0?
Yeah, that makes sense.
Okay.
Okay.
All right.
Sounds like we have a multiplicity of 2 for the 0 that is 0. Now, I don't know what Mr. Bobby does, but at the point that you get a polynomial that has 3 or more solutions, I like to write them out in a set because it helps me kind of think about, do I have the right number of solutions? And then also, do I know how many times each one of those solutions happened? So we haven't talked about the fundamental theorem of algebra yet, but I bet you already know from a previous math class that if it's x to the third, that we should expect it to have 3 solutions. So right here, I've got a positive 0 and a negative 0, which in case you don't know is really just 0 twice, and then 4.
Okay. Now, so, and I found all the zeros. There ain't no more because, like Miss Young said, it's a third degree, so I should have 3 zeros. There should be a matchup between those.
You have six fingers up.
Well, I meant 3 for the degree, and then 3 for, that was like different hands. This is degree. And
this is the degree, and these are the equation. I mean, these are the solutions, and they match each other.
Yeah. But, and that happened before when we had, in the previous video, we had 4th degree. We had plus or minus square root of 7 plus or minus 2i. We actually had real or imaginary solutions, or multiplicity. Multiplicity, that exponent said that the 0 actually like occurred twice, and that's what causes it to bounce.
Yeah.
Now, I also could find the y-intercept. The y-intercept will be what would happen if I put 0 in for x. What's going to happen to this equation if I put 0 in for x?
Well, I'm going to get 2 times 0 cubed plus 4 times 0 squared, which is just 0.
So I'm going to get, -2 times 0. Plus 4 times 0, which is big old 0.
Yeah. So when you plug x in for 0, x is 0 and y is 0, making the y-intercept the origin 0, 0, which isn't very exciting because we already had that point plotted.
I already had that point. So actually, y-intercept and the x-intercept is the same in this problem, which is probably not the best problem I've ever done in my life, but that's okay. So I've got to connect, and I also know that this, I'm going to do this in a different color because I don't want this to stay permanent. I know that at 0, the graph's got to do this, or the graph's got to do this. Okay?
Yeah. Remember, multiplicity 2 means it's got to be tangent to or bounce off the x-axis. So it could bounce above, could bounce below.
And since I know that the left side has to go up, it's got to be like this.
Yeah.
So that part below, that really was just me kind of like thinking out loud. It really isn't there. Okay? So I expect the graph to do this. Oops, I hit the erase instead of the pen. I expect the graph to do this, come up, and come back down through this point.
Yeah. Now, in the instructions, you had 5 steps to follow. Your 5th step, I believe, was if you need a point, right? So one of the reasons you might need that is because we guessed, or he just guessed at that turning point. Could be way up high, could be even lower than that, we're not sure. So what we could do is we could find, W of 2 is exactly what I was thinking, that halfway point between 0 and 4, where we expect that somewhere around there is where that little local max or relative max is going to occur. So we've got what? -2 times 8, which is -16.
What is that? Squared. So we're going to get.
I feel like I just did something wrong.
Oh, you know what I did this whole problem wrong was this should have been a silly Mr. Bobby.
See what happens, guys? When we checked another point, we found we got 0, and we're like, that's not a maximum. So he factored out a -2, and then the number stayed 4, and it should have become 2. So you guys all probably caught that like 7 minutes ago when we started working this problem.
And you're laughing.
You're right.
Yeah, and you're laughing at me. That's okay. It's my first mistake ever. But I do have, so I can catch myself, and I know, because I know this is 0 over here, which reinforced the fact that I was being stupid. And I can't believe how many, so it goes here and here.
Neither of us caught that.
Yeah. And I know that this end has to go up and it's going to bounce and then it's got to come back down through this.
Yeah.
Right? So now actually what I want to do is find W of 1.
Yeah.
That might be a helpful point to find. And that's going to be.
Yeah. And this one's actually a lot easier because we just have negative 2 times 1 plus 4 times 1, or negative 2 plus 4, which is 2.
So I would go to the point 1, 2. It's got to go through that point and come back down.
Yeah.
Okay.
Now, guys, I want to clarify this. That doesn't mean that 1, 2 is for sure our local maximum or relative maximum at that point. That means it's roughly at that spot. We're not guaranteed symmetry of those turning points between the zeros, right? It could be a little to the left or the little to the right of that 1, but we know it's going to be somewhere around the point 1, 2.
Yeah. And I think I did a calculator video about finding maximums and zeros.
Yeah.
You can see that to find use your calculator to find it.
So we could actually check this because we pre-plugged this in. You're welcome, people.
Oh,
you don't have to watch us type in this time.
Can I clear the ink now?
Yeah.
Please do. Okay.
Please clear.
There's the graph. I plugged it in. You can see the equation here. And
yeah. And you can actually see here that little relative maximum is actually a little to the right of 1. So if we use the calculator to find that relative maximum, we're probably going to find that it's not the point 1, 2 because we were just guesstimating.
Yeah, so it's actually at 1.33 and 2.37 is that maximum point.
So 1, 2 is on the graph. It is a point on the graph. It's just not quite the maximum.
You're like sitting right on the max right now, by the way.
Hey.
Your face is at the max, but I'm higher than you because I'm more important. Anyway.
Rude.
Rude, I am. All right, back to the, so let's move on to the next problem.
Maybe let's not make a mistake this time.
Maybe that would be a good idea. We'll try. I mean, I didn't mean to make a mistake last time, so, but I did. It was my first mistake ever. Wow. All right, so let's try factoring this one. Oh, first of all, what do we
do the end behavior first?
Let's do the end behavior. I'm sorry. What do you expect about looking at this term right here?
Well, it's positive.
Right.
So overall, I expect it to be increasing.
Okay.
And the degree is even. So I expect the ends to go in the same direction. So they're going to have to go in the same positive direction.
Something like that?
Ooh, that's a lot of wiggles.
There's too many wiggles there. I should actually, but I don't care. I know there's something in there, but I know both ends are going up. Okay? That looks like a creepy monster, but now let's factor it.
It does.
So, well, you know what? I actually like to do the y-intercept first because it's really easy. Why do I
So you want to find Q of 0?
Yeah, if I do the y-intercept, that's when I have to put 0 in, right? What's going to happen when I put 0 in for all them x's?
I'm going to get 0 minus 0 plus 9.
0 minus 0. There's that negative 0 again, plus 9. So that equals 9. So I got my y-intercept. Can we generalize this to say that every time this number on the end, that's going to be my y-intercept?
Well, as long as it doesn't have an x on it.
As long as it doesn't have an x on it, there's just a constant number. That's going to be my y-intercept.
Yeah.
Okay. Now we're going to factor this one, or set it equal to 0 and factor it, I should say. How about me messing up and fixing it? I meant to do that all along.
I bet you did.
This one feels familiar. We've done this a couple times, right?
We have. You've got that 4 exponent being twice as big as that 2 exponent, telling you could probably factor it.
It's almost like I knew you might have to do this in the polynomial unit, which is why I did it back then. But, never have a plan or anything. What numbers multiply to make positive 9 and add to make negative 10?
Negative 9 and negative 1.
Okay. And I recognize those by now as the differences of perfect squares.
Yeah. I
And
feel like we could just call this +or-3 and +or-1, and kids could get there on their own.
I bet you're probably right. These are smart kids, and they're at Lakeside. It's not like they're from Benton or anything.
Whoa.
Wow. Wow. Yeah, my Miss Watson teaches at Benton. So, all right. So, anyway, that means I'm going to have a 0. Whoa, I'm off on my orientation there. My graph alignment of my marker or something. So I'm going to have a 0 here, 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 and here. I got to connect those 5 dots in a W-like fashion. Okay. So there were both ends are going up, and I got the wiggles in the middle. If I wanted to, I could find the values at 2 and -2, but I don't want to right now, and I'm not going to require that of you.
Yes, he's lazy.
And I got a W-like fashion that goes through those. Now, granted, these points right here and here, they're probably wrong. I'm willing to bet they are. Okay.
Well, let's take a gander at the calculator, Mr. Bobby, and see if they're wrong. Do you think that we should talk about domain and range at this point? Because this one we're currently looking at right now doesn't have a range that goes forever and ever and always.
No, but it does. I do need to find those minimum points. Okay. Now I have the right shape, right? So let me clear this out. And I know, I mean, it's not at 2. I know that it's not at 2 because I go down. It doesn't look like it's quite there. So what I'm going to do is do menu, trace, graph trace. There is a minimum feature, but I like this guy instead. It tells me that the minimum appears to be at -16. Okay. And the minimum value.
Yeah.
The X value of that is 2.24. And I'm willing, because this graph has some nice symmetry to the zeros, it probably has some nice symmetry to the zeros as well. So it never goes below -16. So you want to talk to them? I mean, that's not actually asked for in this lesson, but we can always.
It isn't, but we could very easily throw this question at you. It's like, hey, what is the range of that function you just graphed?
And my minimums were way down lower, right? So I totally messed it up in terms of the minimums, but that would tell me my range. Oh, let me grab my marker here. So tell me about my range then.
So my range are going to be all y values have to be greater than or equal to 16.
Or -16.
Or -16, because 16 would be way up there.
Yeah, 16 be up the top.
Yeah.
In that graph, that's the lowest point on my graph is at -16.
Right.
Do you want to mention the domain?
I mean, it's a polynomial. All polynomials can take in any numbers they want. All polynomials will have a domain of all real numbers. They are accepting of all the numbers.
Inclusive. That's the beauty of math. The math is the only place that everything is truly actually fair.
Well, except division by 0 with rational functions and imaginary numbers with the square root function.
Yeah, all right, so maybe not. I mean,
those are the sticklers.
All right, well, we'll forgive.
But the polynomials, they love all the numbers.
Yep. All right, so let's, we cool? They love all the x's. So anyway. All right, moving on.
True. They love all the input.
All right. So that's example 2. Thankfully, there's only 3 here. And look, I already factored it for you. You're so welcome. All right, maybe
I mean, thank you. Thank you so much. You're welcome.
Right.
You're welcome. So great.
I immediately pick off my zeros by knowing that opposite thing we did. I know I've got one at 1, and I've got one at 3. I've got my 2 zeros at 1 and 3.
Mr. Bobby.
What? I don't like that thing out front. Oh, that thing out front.
If I were to think about this expanded, wouldn't there be 2 factors of that one guy?
Yeah.
Wouldn't there be 2 of those ones?
Yeah.
So that's probably kind of important to tell them.
Yeah, I was getting there, but like I thought I was done. I had all my zeros.
And don't you have an X factor that you've left out?
Yes, I did it again.
You're a math bully.
No, you're just.
Don't leave anyone out.
Okay. So, all right. Now I actually. So that tells me how many X's do I actually have is 4. This is actually a 4th degree. Okay. Like, is that a black belt?
A 4th degree polynomial?
Yeah, that's like. This is like the Chuck Norris of polynomials.
I don't think so.
Okay, so I have to have a W, but I only have 3 zeros. Well, I only have 3 x-intercepts, but this guy, he's going to bounce.
Yeah.
Okay, so I need him to bounce, but I also need to think about now I don't have a leading term. Like, this is harder because before I had like 3x squared or 7x to the 5th or whatever. I had a leading term, but I ain't got no single leading term in this case.
Can we change this problem right here in the middle?
Why?
Well, because I want it to be negative, because we haven't told them what happens when you're trying to do this, but there's a negative out front.
You want to put a negative in front of there?
Yeah, can we do that?
I'll have to change it in the calculator when we get there, but I can do that. So
Okay.
You're the boss. I have to do, well, no, you're not the boss, but you tell me what to do, I do it.
So guys, I just want to change this problem for you. So if you ever run into one of these problems where the leading coefficient is negative, you know what to do.
So that tells me I know it's got to go like this, and then there's some wiggles in the middle, right? Now that we've changed the negative. Okay. So.
And do we need to find the y-intercept if we know one of the x-intercepts is 0?
No, because that y-intercept, but I'm still having trouble finishing this graph. Like, I know that I'm going to, now this is going to be real rough. I know it's got to like come down this way, and I know it's got to come down this way.
Yeah. And it has to pass through the x-axis at 0, and it has to pass through the x-axis at 3, and it has to bounce off the x-axis at 1.
So I got to have like a little smiley face there. Oh, wait, I can do that. I can connect those guys and bounce there, and then I can like maybe connect them like that. And this is a terrible, terrible sketch of it, but that has more to do with my artistic abilities. I have the right ideas here. Okay. Yeah. So now it's going to be wrong in the calculator. Like close your eyes.
Put a negative in front of it. They might appreciate what this looks like.
Yeah.
All that's going to happen now, guys, is it's going to reflect over the x-axis. Are you ready for it?
Graph, and if I change it, and look, it's pink.
Ready? Ready? Ooh.
Don't be all snotty, all right? Just because I changed gears on you in the last lesson. You changed this lesson, but it has those same properties. Now, I don't have the heights of my peaks. That's what we're talking about. I could find more points to get a refined graph, but I only really need you to find the x-intercepts, the y-intercepts, the behavior of the crossings, the multiplicity of zeros, and that end behavior. And really, there wasn't anything new in this lesson. We just kind of put it all together to make a graph. And then you can confirm it with a calculator, or I could totally see me giving you a problem, like giving you an equation and giving you the graph and say, why isn't this the graph of a problem or something like that? So, hey, there's another test tip.
Yeah, I like that test question, actually. I don't think I've ever written one like that, but I think it's smart.
I don't know. I mean, I have to, I'll probably forget it. Oh, well. All right. So maybe not. It's recorded. So anyway, there's your practice problems for section 4.2. I hope you have a happy, wonderful day.
Bye, guys.
Bye.